Okay, so in this video, we're going to take a look at some basic CANBUS diagnostics. We have a simple CANBUS circuit shown here. This circuit includes a couple of controllers. It has two terminators, and those two terminators, one's a passive, one's an active. If we highlight what's inside of the terminators, there is a little resistor between CAN high and CAN low. CAN high and CAN low are shown in yellow and green here. The job of the active terminator is to set up a carrier voltage in CAN high and CAN low. So that carrier voltage in CAN high and CAN low, does anybody know off the top of their head what that carrier voltage normally is?
.5-ish.
Okay, so that means that if I was measuring the voltage on CAN high and CAN low, I should end up with a voltage of 2.5 to say 3.5 on CAN high, and 1.5 to 2.5 on CAN low. The reason why there's a difference in voltage there is because of how the CANBUS system works, how the information is communicated on the CANBUS. So CAN high, the way that we pull CAN high up is we connect CAN high to a 5-volt source inside the controller. We take CAN low, and inside the controller, we'll connect it to ground. And we do that simultaneously. So if I want to send a message down CAN high and CAN low, remember, digital information is just simply a change in state from on to off. And in this case here, off is where we just have a steady 2.5 volt carrier voltage established on CAN high and low. If I connect CAN high to a 5-volt source, that pulls the voltage up. If I connect CAN low to a ground, that pulls the voltage down. And that's the reason why we end up with CAN voltages on a working CAN system that look like this. If there's no communication happening for whatever reason on the CANBUS system, your CAN high and your CAN low, they're not going to be doing anything. So it's just going to be sitting at a steady 2.5. If we don't have a 2.5 volt carrier voltage, that means that our active terminator or whichever controller it is that's acting as the active terminator has failed. Something that we have talked about is that it's it's not very common. Every machine I've ever dealt with has a way for you to connect a diagnostic tool to the machine. That diagnostic tool connects to your diagnostic test port. And the diagnostic test port on the machine is where you'd hook up your data link to the DTC and also to your laptop. Okay, so there's your laptop, there's your data link. Your data link is going to have a USB cable. That USB cable may or may not need to be connected to a particular port on your laptop. Your data link is acting as a translation device between the CAN and the computer. When we're looking at the DTC itself, there's 2 ports on there that we would normally focus on, and those would be C and D, all right? C and D are CAN high and low, typically. I'm not gonna say on every single machine, but typically those are the ones that we're gonna focus on while we're doing some basic testing on the CANBUS system. The CANBUS system is set up such that we send digital information down CAN high and CAN low, and every other controller on the CANBUS is listening for messages to come down the line. But because that's electrical information that we're sending broadcasting out onto that CANBUS, what we have to do is we have to dissipate that somehow after that message has been received by all the controllers. And that's where the terminators come into play. A terminator is simply a 120 ohm resistor. That's all a terminator really is. For the standards that we use for CANBUS, they've adopted, I should say, 120 volt terminating resistors as the standard. So that means that I have typically two, sometimes one if it's a very small CANBUS system, but typically two 120 ohm resistors in the system. If both of those resistors are good, the system works as it should. If one of them is bad, you're going to have trouble dissipating the energy of the communications on the CAN high and low, and you may end up with some garbled communication. If they've both failed, there's nowhere to dissipate that energy into. And even though the controllers are trying to communicate, it's like a whole bunch of people talking in the same room and not anybody taking their own turns, and basically the walls echoing like crazy. That's kind of what happens here. And that means the communication is nearly impossible, if not 100% impossible to happen. So terminators, one or two. If you have two, then your CAN high to CAN low, if you measure across C and D at the DTC, should read 60 ohms if you have two intact terminators. If it's anything other than 60 and you've got two terminators, chances are it's a blown terminator. It doesn't have to be a blown terminator. It could be an open in one of the harnesses. All right. If you had two blown terminators for some reason, then you're going to end up with kilo ohms of resistance on a machine where you only have one terminator and that terminator is faulty. You're going to have kilo ohms of resistance. And the reason you have those kilo ohms resistance is because at that point, the only thing that you're measuring is the internal resistance of the CAN transceiver node in each of those controllers. One other thing that we did talk about is sometimes we have sensors and actuators that run on a little secondary mini CAN. There's a name for this. Could be called a secondary CAN, could be called a LIN bus, okay? But when we connect another smaller secondary CAN just to a single control unit, this right here is where we have smart sensors and smart actuators, and they don't communicate on discrete wires like a typical sensor or actuator normally would. All right. So this would be LIN bus or secondary CAN. These would be discrete sensors and actuators. That's the difference.
So the LIN bus is the secondary CAN?
The LIN bus and secondary CAN, those two terms are used interchangeably as far as I'm aware inside this industry. There are other types of data buses out there. USB is actually one of them. It's Universal Serial Bus. Modbus is something that is used in industrial PLCs and things like that. What we use in machinery that we're familiar with is usually CANBUS of some flavor. Okay. So taking a look at this, we can see that if I've got a CANBUS system, some of the basic testing that I can do is a resistance test to see if the CAN is physically intact or if there's a blown terminator, broken wire, something like that. That's a resistance test at the DTC. If I got two terminators, I'm looking for 60 ohms. One terminator, 120 ohms. If I'm in the kilo ohms, I've got big problems. A resistance test is always done with the power off. The next thing I'm going to do is switch my voltmeter or my multimeter to volts. I'm going to go turn the power on to the machine, and I'm going to check and see if there is communication trying to happen. So with my multimeter connected to ground, I check CAN high. Okay, so I go over there, I check CAN high, and I expect to see 2.5 or greater. Then I'm going to take my multimeter and I'm going to connect it to CAN low, and here I expect to see 2.5 volts or less. What's really important is that I have a spread between CAN high and CAN low. That spread is telling me that I am trying to pull CAN low down below the carrier voltage, and I'm trying to pull CAN high up above the carrier voltage. The greater the spread, the more communication is trying to happen. So if I've done my resistance test and I've done my voltage test, and everything seems to indicate that communication should be able to happen, but communication isn't happening. And when I say communication isn't happening, maybe I'm trying to scan this thing. I'm trying to figure out if, I've got some fault codes, or if there's a reason why there's a problem with that machine. Then some of the other things that could be a problem, USB cables. USB cables and communication cables between your data link and your diagnostic test connector, those cables can fail. Your data link is another point of failure, possible. I'm not saying it happens very often, but of those three things, the one that tends to be the cord that always gets stomped on and bent and abused the worst is the USB cable. Another thing you should be aware of is some USB cables have to be plugged into a particular port on the machine because there's something called port mapping on that laptop. So your USB ports, they all have assigned numbers as far as the actual computer itself is concerned. And that laptop, if it knows that when you open up, say, CAT-ET service software, it's going to look at port number 4 for a COM2 or a COM3 adapter, then if you plug the link, that COM2 or COM3 adapter into the wrong USB port on the machine, it won't recognize because it's not looking at that port. It'll just say there's no connection. So that's called port mapping. Less and less service software nowadays is tending to do that, but it is definitely something to consider. If you got no connection, try a different port first. Try all the different ports on your laptop. If that doesn't do it, try a different USB cord. Okay. So I think that pretty much wraps up your basic CANBUS diagnostics. That should be helpful to anybody who wants to review this going forward.